Hello viewers. So in today's class we are going to take up one more important problem from differentiation, and here we have this problem, that is, if sine square y plus cos xy is equal to k, we have to find the derivative at x is equal to 1 and y is equal to pi by 4, right? So let us start. So here we are given sine square y plus cos xy is equal to k. Now here we take k as a constant, and this xy is inside this cosine function. So here we have the variables x and y, and we have to find dy over dx. So let us differentiate both sides with respect to x, right? With respect to x. So we have d over dx of sine square y, then we have d over dx of cos of xy, and here we have d over dx of k, right? Now we know that the derivative of a constant function is 0, so we have here 0, right? Okay, now here we have sine square y. So first we'll apply the rule, that is the power rule for differentiation, that is dy dx of x raised to n is nx n minus 1. So here we have first we have 2 sine y, right? So first we have here 2 sine y, and then we'll write the derivative of sine y due to the chain rule, right? Okay, now here we have the cosine function. So the derivative of cos xy is minus sine xy. The derivative of cos theta is minus sine theta. So here we have the derivative of cos xy as minus sine xy, and then by chain rule we have to differentiate the product x and y, right? And this is equal to 0. So now we have 2 sine y, and here we have to differentiate sine y with respect to x. So again by chain rule we can write d over dy of sine y, and then we have dy over dx here minus sine xy, and here applying the product rule, and the product rule says that if we have u and v, then this is first function derivative of second, then second derivative of first, right? So here we have d over dx, here we have x, then dy over dx plus y, and derivative of x, and this is equal to 0, right? Now here we have 2 sine y, derivative of sine y is cos y, and here we have dy over dx minus sine xy, and here we have x dy over dx plus y is equal to 0, because the derivative of x with respect to x is 1, right? Now 2 sine y cos y is sine 2y, because sine 2 theta is equal to 2 sine theta cos theta, right? Okay, so we have sine 2y here, then dy over dx, and minus x sine xy, and dy over dx, and minus y sine xy, right? Okay, now we'll rearrange this expression by taking this dy over dx as common in these two terms. So we have sine 2y minus x sine xy, and here we have dy over dx, and taking this term to the right hand side we have y sine xy, right? So now we can write dy over dx as y sine xy divided by sine 2y minus x sine xy, right? So this is the final expression for the derivative of y with respect to x. Now we have to find the value of dy over dx at x is equal to 1 and y is equal to pi by 4. So what we will do, the product of x and y is 1 times pi by 4. So we have pi by 4, and if we substitute these values over here, then we get dy over dx is equal to y is pi by 4, and here we have sine xy, and xy is pi by 4 divided by sine 2y, and the value of 2y is 2 times pi by 4 because y is pi by 4, and here we have pi by 2, right? So here we have pi by 2 minus x is 1, and here we have sine pi by 4, right? And we know that the value of sine pi by 4 is 1 over square root of 2. So here we have 1 over square root 2 divided by sine pi by 2 is 1, and here we have 1 over square root of 2. Now let us simplify this expression. Now dy over dx is equal to pi over 4 root 2, and here we have a square root of 2 multiplying 1 by square root of 2 minus 1 over square root of 2, and this can be written as pi over 4 root 2 multiplied root 2 over root 2 minus 1. Root 2 and root 2 get cancelled, so we have pi over 4 times root 2 minus 1, right? So we can take this value as our final result, but if we wish to simplify it further, we can multiply and divide this expression by square root of 2 plus 1 and square root of 2 plus 1, right? So rationalizing the denominator, so here we have pi root 2 plus 1, and here we have 4 times this is a minus b, this is a plus b, so we have a square minus b square. So here we have root 2 square minus 1 square, that is 2 minus 1, that is 1. So here we have 1, right? So we can finally write this expression as pi by 4 times square root of 2 plus 1. So this is the final result.